So our second of the 6 topics are about the type system embodied by the language, and I'm going to turn it over to you now to give us a definition of what is a type system.
So a type system is probably the most significant choice that you have to make in deciding when you're designing a language. And the question is, how do you determine the types of variables? Is the variable A an integer or a string? What choices are there? Do you have pointers? Do you have to tell the compiler what types things are, or can it figure it out itself? Or does it wait till runtime to figure out what it's doing?
So now you've started to dive into this list of 3 different ways of differentiating type systems. And that last thing you said really has to do with dynamic and static. So that's really when do the types get defined? So if it's dynamic, the types get defined at runtime, versus static, the types are defined when you compile the file.
Yep.
So far so good?
Correct.
All right, so what about safe versus unsafe? What does that mean?
So a language like C is unsafe because the compiler doesn't guarantee that the types that you tell it are really correct. You can have a pointer to a string and tell the compiler that it's a pointer to an integer, and it'll just try to do the code for the thing you told it, and if that results in things crashing horribly and side faulting, that's what will happen.
So at compile time, you've specified what something is, but you can lie? Is that what it's about?
Yeah. And this is wildly useful for writing efficient programs, as anybody who writes C code can tell you that you want to fiddle the bits. And
so why don't you just say, I've got some bits and I'm going to fiddle them? Why would you say anything other than that?
Because in C, it's hard to tell the compiler that you have bits. You say you have characters or something.
Uh-huh. So, well, there, you're just basically able to do whatever you like, and the compiler will let you, and that's why it's unsafe.
And really all you have in C is an array of bytes, and it's memory, and you do whatever you want, and types are just convenience to...
So can you have a dynamic and safe environment? So you're creating your types as the program runs, but it's safe somehow? Is that possible?
Yeah, Python is like that. In Python, every variable remembers its own type, and you can assign a new value, which is a different type to that variable.
And then what happens?
And then it remembers its new type, and there's no problem.
How is that safe, though?
Because you can never perform an operation on a variable that isn't defined for that type. If you try to add a string to another string, it might be concatenation. Whereas if you try to add 2 numbers, it's addition.
Well, so this is the compiler's figuring out what add means depending on the context of the 2 types.
Right.
Okay.
And if you try to add some type where add is undefined, it will give you an exception, and you can catch that.
So you get a runtime error rather than your system crashing.
Whereas in C, if you try to add 2 strings, it'll add the pointers or something, and who knows what will happen.
Okay. And what about permissive versus strict? What is that idea?
So in some languages, you can cast between different types, and that'll do something well-defined and meaningful. And in other languages, casts are largely disallowed. For example, in Haskell, which we'll be using a lot this semester, you really have to go to a lot of effort and dig down into things that are clearly labeled as you should never do this if you want to try to tell it that it should treat even a floating point number as an integer.
So Haskell is strict in that basically, unless you do completely unusual things, you cannot cast one type to another.
Right.
And how is that different from safe versus unsafe?
It's different from safe versus unsafe in that safe is saying that everything's going to be well-defined, whereas permissive versus strict, in a permissive but safe language, everything is still trying to be well-defined. You just, a strict language will protect you from doing casts that will result in runtime exceptions.
Do we have an example of a permissive and permissive and safe language?
Java is permissive and strict and safe.
So we can cast things all we like.
But we'll get runtime exceptions if we get it wrong.
Oh, very good.